Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In today's video, we're going to talk about loads and materials, and this chapter is taken from the book Shikni Mechanical Engineering Design. Okay, let's begin. Choosing loads and materials, uh, choosing unit loads and bearing materials. Okay, some help in choosing loads and bearing material is afforded by table 12.5 and 12.6. Okay, this is the table 12.5. Since the meter and length of a bearing depend on the unit load, these tables will help the designer to establish a starting point for the design. Okay, so somehow it gives you guidance. Let's say you want to use diesel engine, crank pin, wrist pin. Okay, these are the loads given in PSI and also in megapascal. Okay, electric motor, steam turbine, and a crank pin, air compressor. At least you have some guidance what you want to do, what pump you want to purchase, and everything. What motor, how many power of a motor you have to purchase, and everything you have some guidance of it. Okay, some this 12 table 12.6, some characteristic of bearing alloy. Okay, this is the bearing alloy. Lead base bead, thin base. Okay, we will talk about bead in subsequent slides. There is a slide on bead itself. Okay, lead base bead, lead bronze, and this is the thickness. This is SAE number, clearance ratio, load capacity, and corrosion resistant, and all of these things. Okay, so thin film lubrication conditions. The length diameter ratio L over D of a bearing depends upon whether it expected to run under thin film lubrication condition. A long bearing, okay, long bearing meaning that large over length over diameter ratio. Okay, let's say this is long bearing. Okay, that ni it is length, this is diameter. Okay, reduce the coefficient of friction and slight flow of oil, and therefore desirable where thin film or boundary lubrication is present. On the other hand, where force feed short or positive lubricant is present, the L over T ratio should be relatively small. So what is mean by that is one is big, one is long, one is small. Okay, if you want to use the pressure effect, you have to use small, short bearing, short general bearing, short shaft. Okay, um, because logic uh, pressure distribution in short shaft is distributed evenly, but if a longer shaft, it will not distribute longly, it will not distribute evenly. Okay, so short bearing results in greater flow of oil out of the ends, thus keeping the bearing cooler. Current practice is to use L over D ratio about unity and general to tend to increase this ratio if thin film lubricant is likely to occur, and decrease it. Okay, for thick film lubrication or high temperature, if shaft detection is likely to be severe, short bearing should be used to prevent metal to metal contact. Okay, there is maybe for some of your application, deflection may happen because of many reasons. Okay, deflection. Okay, the bearing become deflect for many reasons. You will know what the reason. Maybe you apply more load. Maybe accident happen. Maybe crash happen and everything. So it will bend. And when it will bend, okay, let's see that I fold this cardboard like this, bending like this. So at this region, metal to metal contact will happen. This region, metal to metal contact will happen. We want to avoid it. Okay. Uh, using short bearing, this can be avoided. But using long bearing, deflection will happen. Okay. So use partial bearing if high temperature. You should always consider to use of partial bearing if high temperature are a problem, because relieving the non-load bearing area of a bearing can be substantially reduce the heat generation. Okay, so this is a partial bearing, this is the full bearing or the full bearing. You can imagine the shaft is full of lubricant. Okay, the shaft is full of lubricant. Of course, the heat distribution will be full. Okay, but if the shaft is not full, only half full of lubricant, let's say the lower part only full at the lower part. Okay, and then when it go up at the upper side is no lubricant, so the the heat will distribute evenly. Okay, the heat will be lost at the upper part of the shaft. So that is why if you are using high temperature, if you're using it in high temperature, use partial bearing. Do not put it full of lubricant. Okay, two conflicting requirements are number one, requirements of good bearing material are that if have must have a satisfactory compressive and fatigue strength to resist the externally applied loads, and that it must be soft and have low melting point and low modulus of elasticity. Okay. Second set of requirement necessary to permit material to wear or break in, since the material can then conform to slight irregularities and absorb this the release of foreign object. The resistance to wear and coefficient of friction must also important because all bearing must operate at least for a part of time with thin film or boundary lubrication. You try to understand this both of these conflicting requirements, meaning that must have a compromise for these two conditions. Okay, both are good. Okay, additional consideration in the selection of a good bearing material is ability to resist corrosion and of course the cost of producing the bearing. Some of commonly used material are listed in table 12.6 together with their composition and characteristics. Okay, so increasing bearing life. This is the baby. Okay, I take this picture from Google Image. Okay, bearing life can be increased very substantially by depositing a layer of baby or white metal in thickness from 0.01 to 0.014 in over steel backup material. Okay, in fact, a copper lead layer on steel to provide strength to combine with babbit overlay to enhance surface conformability and corrosion resistance, making an excellent bearing. You may want to use babbit to increase your bearing life. Okay, improvement over solid bearing material. Small bushing and transcoilers are often expected to run with thin film or boundary lubrication. When this is the case, improvement over a solid bearing material can be made to add significantly to the life. A powder metallurgy bushing is porous and permits the oil to penetrate into the bushing material. Sometimes such a bushing may be enclosed by soap material to provide additional storage space. Bearings are frequently ball indented to provide small basins for the storage of lubricant while the journal is at rest. Okay, this applies some lubricant during starting. Another method of releasing is to indent the bearing wall and to fill the indentation. Okay, what does it mean by this? Okay, for this journal bearing, you may want to make some indent. Okay, make some indent like this. Make some indentation. Let's say indentation like I'm pushing my hand over this cardboard, and this because of I'm pushing this part, there is a slight indentation. You cannot see, but there is a slight indentation here. This indentation, the oil will come to this. The oil will go down. Okay, some of the oil, meaning that when you start the material, it's not totally zero lubricant, because zero lubricant you will have metal to metal contact, and when metal to metal contact happen, your bearing will become wear and tear gradually over time. Okay, meaning that uh, there is one video I talk about this metal to metal contact. uh, your bearing, if metal to contact happen at extreme case, you may feel with your finger there is a groove inside it, which is not good. Okay, you want to avoid metal to metal contact, you make an indentation. Okay, make an indentation in the bushing so that some of the lubricant will fill the indentation, and when the journal start, let's say you switch off the machine at night, and then tomorrow morning you come and you on the machine, and when you on the start machine, okay, some lubricant is there, so it's not totally zero lubricant. Okay, this lubricant will provide some layer, okay, layer, so that metal to metal contact will not happen. Okay, so select lubricant with all these tentative decision made. A lubricant can be selected and hydrodynamic analysis can be made. Already presented these values of the performance parameters is plotted in figure 1225. For example, we then indicate whether a satisfactory design has been achieved or additional iterations are necessary. Okay, so that's all for this video. We see you in the next video on bearing types. Okay, thank you very much.